Good afternoon, everybody, and welcome to this Euresys presentation about line scan application. The development of a line scan application is often perceived as much more complex than the area scan counterpart. And in this presentation, we will detail functionalities offered by the Euresys frame grabber that simplify the development and the setup of line scan applications. But first, let me start with a very short introduction about the Euresys company. Okay, so Euresys is a manufacturer of machine vision components. So our headquarters is in Sorin, which is located in the eastern part of Belgium. We have R&D teams in Belgium and Germany. Euresys also has sales and support offices in Europe, USA, Singapore, China, and Japan. And currently our staff counts 85 employees. So 50% of us are working for R&D. So Euresys also benefits from an extensive network of distributors, and we are renowned for providing high quality products and premium support to OEM and system integrators. So at Euresys, we offer three types of products. We are, of course, very well known for our frame grabbers that have been used in the vision industry for more than 30 years now. In addition to frame grabbers, we also develop and produce IP cores for various interface standard and imaging sensors. We also provide a complete range of machine vision software libraries known as inVision. Those libraries are dedicated to the development of 2D, 3D, or even deep learning-based applications. So now back to our subject, the line scan application. So I start with a little bit of basics about line scan acquisition. So a line scan camera output one line at a time. So the construction or the reconstruction of a 2D image will therefore implies motion, movement. Typically, it is the object or the web which is moving under the camera. To avoid deformation due to speed variation, for instance, line scan applications usually rely on motion encoders to synchronize the acquisition line rate of the camera with the speed of the object. So all the Euresys frame grabbers, whether they are compatible with the camera link, co-express or co-express over fiber standard, are equipped with a dedicated I/O lines connector to connect the motion encoders. So they even support quadrature motion encoders with a frequency up to 5 megahertz. So as we have seen, the usage of motion encoders is mandatory to achieve a constant aspect ratio of the acquired images. However, obtaining the same resolution in the horizontal and vertical direction, what is typically referred to square pixels, might be difficult because motion encoders featuring the exact required number of pulses per revolution are not always available. So in our example here, we need an encoder which outputs 9,537 pulses per revolution. And of course, I'm not quite sure that such an encoder is really readily available in the market. So to solve this problem, Euresys provides the rate converter. The rate converter multiplies or divides the signal provided by the motion encoder by any rational number. So this allows the camera to acquire lines at any programmable resolution, lower or higher than the resolution of the motion encoder. So this feature is implemented in all the Euresys frame grabbers. Back to our example, the encoder that we have here provides 5,000 pulses per revolution, while 9,537 pulses are required to achieve square pixels. Then in this case, it means that we just need to configure the rate converter to multiply the encoder signal by 1.907. And that's it, the problem is solved. We get nice images featuring nice square pixels. Another situation where the rate converter is of great help is when a land scan application must evolve towards a higher resolution. In this case, changing the camera of a given setup usually means that you also need to change the motion encoder. Thanks to the rate converter, it is possible to keep the same encoder while increasing the resolution of the camera. This just requires updating the conversion factor. So as we have seen, the rate converter gives system designers incredible freedom and flexibility during the development of a land scan application. The trend in land scan application nowadays is to design systems that are as compact as possible. And due to the reduced available space, it is not always possible to place sensors such as presence or proximity detector at the same location as the land scan camera. So when inspecting discrete objects of finite size, presence detectors are usually used to start a new scan. So if a presence detector is located upstream compared to the camera, it is then mandatory to postpone the start of the scan until the object actually reaches the camera. And to achieve this, Euresys frame grabbers are equipped with delay tools that introduce a delay between the object detection and the start of the scan. In case of land scan application, this delay is expressed as a number of encoder tick, which ensure that any speed variation, of course, is taken into account. For some land scan application, especially at low speed or when the application is starting, backward motion might be observed. So in this case, the same portion of the object or the web is acquired several times. First in the initial forward direction, then in the backward direction, and then again in the forward direction. And of course, this will result in distorted images. To avoid this problem, Euresys provides a tool which is called a backward motion compensator. So as already mentioned in this presentation, Euresys frame grabbers support quadrature motion encoders, which means that they can decode A and B phases to know in which direction, forward or backward, a part or a web is moving. So to ensure distortion-free images, the backward motion compensator will pause the line acquisition when a backward motion is detected. And then the line acquisition will automatically resume when the motion is again in the forward direction, but at the exact same place where the acquisition was interrupted, meaning that there is no additional line and there is no missing line. When acquiring images of very large objects, most of the time several cameras are required to cover the whole width of the area to be inspected. And in this case, it is really mandatory to synchronize the acquisition of all those cameras. Euresys frame grabbers support the so-called C2 sealing feature. C2 sealing allows to very accurately synchronize the image acquisition between several cameras. So a dedicated C2 sealing connector is available on the PCB of each of our frame grabber, and the synchronization is managed through a master-slave architecture, which means that the master frame grabber receives all the trigger signal and propagates them to all the slaves, to make sure that all the cameras are acquiring each line at the exact same time. So C2 sealing is able to accurately synchronize cameras that are connected to the same frame grabber, or to different frame grabbers in the same PC, or even to different frame grabbers that are plugged in different PCs. And of course, we do provide dedicated accessories to achieve this task. So here we have an example. We have two cameras connected to two frame grabbers that are plugged into the same PC. And these two cameras must be synchronized. So in this case, we just need to connect a C2 sealing connector to both frame grabber with a dedicated flat cable to synchronize these cameras. So this is the first example. So now if we need to add a third camera to the system, but in this case, the camera is connected to a frame grabber which is plugged in a different PC, the first thing we have to do is to connect each frame grabber to an inter-PC C2C-link adapter in each PC, and then connect both inter-PC C2C-link adapter with a standard Ethernet cable. In this system, we have 3 cameras. They can be synchronized, and the trigger just have to be sent to the master frame grabber. Then the master frame grabber will just ensure that all the slaves will receive exactly the same trigger at the same time. So this allows really the synchronization of several cameras. In large-scale applications, based on the result of the inspection software, it is often required to control external devices. For instance, if you need to reject a defective product. So even though the main task of the Euresys frame grabbers is to acquire images, they can also be used to control external devices, such as status lamp or cutters or ejectors or stampers, just to name a few. So the Euresys frame grabber implements one or several user action scheduler. Those action scheduler, they are used to trigger user events or to toggle the state of the board output line at the predefined time. So in case of LAN scan application, the timing reference is again the encoder tick counter. So as you can see, in case of LAN scan application, the encoder has really a very important role to play. So by changing the state of any output line of the frame grabber at a very accurate time, the user action scheduler allows to control the operation of external devices that are connected to the frame grabber. Before moving on to the next subject, I would like to talk about a specific kind of LAN scan device. Contact imaging sensor, that we also call CIS. They have a very short working distance. Typically, they are placed just 1 or 2 centimeters above the observed object or the web. And this, of course, allows for a very compact systems. When several CIS are required to cover the whole width of the area to be inspected, they are usually staggered. And the reason for this specific arrangement is to avoid losing pixels between CIS if they were placed side by side. For some application, it is necessary to reconciliate images coming from different LAN scan cameras or CIS into a single large image that represents the whole area to be inspected. This is what we call the image stitching. When the CIS are staggered and you need to stitch images, then this operation must solve horizontal overlapping as well as vertical shift. And this operation usually is done by the CPU. It means that it also involves image copy. So Euresys has offered a very neat solution to this problem. The image stitching is actually performed by DMA transfer. So our frame grabbers are DMA agents, which means that they do not need any intervention of the CPU to transfer data into the PC memory. So instead of feeding its own memory buffer, each frame grabber accesses a common big buffer and transfer its image data at the relevant location, taking into account the vertical shift and the horizontal overlapping. So the image stitching is performed on the fly by DMA transfer. It does not require any CPU usage or image copy. So it means that the CPU is just ready and fully available for the image analysis. Another very interesting feature that is offered by the Euresys frame grabber is the metadata insertion. So metadata are additional bytes that are appended at the end of each line. The metadata are used to report the frame grabber IO state, for instance, or the number of lines that has been acquired so far, or the encoded tick position, or the value of a pulse counter or any event counter. So as such, metadata provide a kind of snapshot of the system when a given line was acquired. The goal of the metadata is, for instance, to reconcile images that are acquired by different camera at different locations. Metadata are also especially useful to validate the behavior of a line scan application. They allow to verify that a given line was acquired at the expected time. And this is particularly important when the line scan acquisition involves several strobing sequences, complex strobing sequences. So you have to make sure that the line was acquired when the corresponding strobe light was on. Okay, so as we have seen, the requirement for motion makes the development of line scan application a bit more complex compared to area scan applications. However, we have seen in this presentation that thanks to the rate converter, the delay tool, the backward motion compensator, C2C link, the user action scheduler, metadata, and of course the full control over the DMA transfer, using Euresys frame grabber to develop line scan applications definitely makes it much easier. And this concludes my presentation.
So thank you very much. And now it's time for the question. And the first question is the stitching done in the grabber's memory?
So actually, the stitching is not done in the frame store of the frame grabber. It is done through the transfer, through the DMA transfer. So while the frame grabber is transferring its image data to buffers, this is how the stitching is performed. So it's performed on the fly through the DMA transfer. So inside the frame grabber, we are not reconstructing the image or stitching the image. It is done directly by transferring the correct data at the relevant location.
Next question. What is the maximum multiplication division factor of the rate converter?
So the maximum division is by 1000, and the maximum multiplication is multiplied by 1000. There is a limit, of course. The multiplication cannot be higher than 5 megahertz. But to be honest, I don't know any line scan camera that support a line rate of 5 megahertz. So we have, I think, a comfortable margin regarding this.
And is the delay tool able to manage several events at the same time?
Yeah, it's possible. Actually, the delay tool operates like a delay line. So it may accept a new event while the previous one has not been delivered yet. So it means that the delay tool is able to record a sequence of up to 16 different events. And actually, on the frame grabber, there are 2 delay tools. So you can choose which one you want to use.
Looking at the clock, I think we have time for one more question. And what is the typical trigger propagation delay between master and slaves when using the C2C link synchronization?
So we have to distinguish between synchronization of camera that are connected to the same frame grabber. In this case, it is an internal latency, let's say, and between the master and the slave, we will have something like maximum 5 nanoseconds. If we have to, if the master-slave architecture will involve another frame grabber, so 2 frame grabbers, we have to connect them together with a flat cable. The flat cable we introduce maximum 10 nanoseconds of delay. And if you want to synchronize cameras that are connected to frame grabber that are plugged in different PCs, suppose that we have a separation of 100 meters between the 2 PCs and you still want to synchronize those cameras, then the inter-PC C2C link adapter will add something like between 20 and 40 nanoseconds again.
It seems to have an answer to every question. We will test this after the next presentation when we start the final Q&A. So, okay. Jean-Marie, thanks a lot. So Jean-Marie, there's a question still for you. How many actions can be managed by the scheduler tool at the same time?
So per user action scheduler, there is a pool of maximum 64 actions. But you have to understand that you have to feed new actions in this pool. So it means that when an action is done, executed, it goes automatically out of the pool. It means that you can put another one inside, and you are always informed about the level of filling, let's say, of the pool. So you know exactly if you can add more action in the pool.
Another question to Euresys. Yo provides camera link and coax express frame trappers. Are the features you mentioned in your presentation available for both the areas?
Yes. So for the co-express and the latest generation of camera in-frame grabber, we actually use the same driver, the eGrabber driver. So we have exactly the same functionality, yes.
Once again, if you have any questions to the audience, just use the Q&A section.